And last but definitely not least, I need to test 5 pi over 6. See if you can get the value. Pause the video. Did you figure out that it was negative? And since it's negative, then at that spot, I'm concave down, which means that critical point has to be a relative max. And of course, I could find the y value if I plug back into the original. Yay! Awesome, calculate. Okay, so now remember, when I'm working with radicals or rational polynomials, I always need to start out by figuring out what the domain is. Because if I get critical values that are not in that domain, there's no point in checking them because they're numbers that are not allowed in the graph. So, of course, I know that anything inside the radical has to be greater than or equal to 0. And so when I solve this, I get x is less than or equal to 1. So my domain is negative infinity to positive 1. So if I get anything outside of that, there's no point in testing it. So now pause the video and get me first derivative. So here it is before I do anything else to it. Of course, if I want, I can get a common denominator and turn this into a single fraction, which will be helpful when I set it equal to 0 and undefined. So I'm going to do that next. So hopefully your answer matches my answer. And of course now I got to find the critical values for it. So I'll set it equal to 0. Remember, when I set it equal to 0, I'm going to multiply both sides by that denominator anyways, which will make the denominator cancel out. So really, it's like setting just the numerator equal to 0. And now I want to solve for x. Of course, remember that's really a square root function, so in order to get rid of it, I'm going to square both sides. So I have 1/4 equals 1 minus x, and then with a little mathematical hocus pocus, I get 3/4, so there's a critical point. And then I'll set the denominator equal to 0, because that's what makes the graph or the function, the slope, undefined. And so when I do that, I'll divide both sides by 2, so that's gone. Then, so it's like it just cancels out, since 0 divided by 2 is still 0. And then I'm going to cancel both, I'm going to square both sides. So I still get 0 over here, and then I'll get x equals 1. So now I have to look back and go, oh wait, how does 1 fit in? Well, it is an end point, so I'm not actually surprised. It's quite possible that that could be a max or a min, the endpoint, right? Because we've tested endpoints before. Okay, so now I need to find the second derivative. So find me the second derivative. And let me make a suggestion that you use the original version that you got before you got a common denominator, because it will be much easier to take the derivative on that than it will in the common denominator form. Okay, so check your first step and see if you had that. Of this in the very beginning, of course, is the derivative of the 1. And then I have low d high. This is the d high. So of course that's all going to just cancel out. And then minus high d low, all over low squared. Remember, if I square this whole bottom, I'll get a 4. And then this will cancel out the square root. Okay, simplify that top. Don't forget that you still have that negative out front. And then I'm going to simplify one more time, and hopefully you have that. Okay, so now we're going to take our values and we're going to plug them into second derivative.